Good afternoon, everybody, and a very warm welcome. Thank you very much for joining us here. What I'd like to do is start off with a little bit of background to this project, and then I'd like to introduce my co-presenter, Alan Harvey. I suspect, after the events of the past few weeks, he needs no introduction, but I will give him his proper dues. So, I'd like to start the story back in 2015, when I started talking to publishers. Because my company, Yewno, uses artificial intelligence, and we create this very different type of discovery environment. And to create it, we use algorithms, and the algorithms extract meaning in the form of concepts, they create connections and inferences, and then we're able to visualize them, as you see on the screen here, to help researchers find what they're looking for, to find unexpected connections, and then to get to the documents thereafter. But to do that, we own the technology, but we needed really, really high quality content. So I started talking to publishers, and as I was talking to publishers and I was explaining about the product that we were building, I had to explain how the technology worked. And as I explained that the algorithms were going to read the full text, publishers started saying to me, well, if you're going to read the full text, I wonder if you can help me with my metadata. And some people said, well, my metadata is a bit out of date. Some people said, well, I've only got one BISAC code and I'd like to have 3. Some people said, I've only got 5 keywords and I'd rather have 11. So there was this huge range of status of metadata. But after a few conversations with publishers, we realized that we could indeed help them improve the quality of their semantic metadata because we were reading the full text. So we created this product called Yewno Unearth. So what Yewno Unearth does is it reads the full text of any item of content, an abstract, a journal article, a book chapter, or a patent, and it will assign to that piece of content the exact percentages of topics and subtopics. It will identify concepts, which you can think of as keywords, but a concept is much richer because it has a pertinence score, it's disambiguated, it has a definition, and then you can use that information to help people find your own content, whether that's on your website, to help people find your content in data feeds that you send to other parties. And so we created this product, and it's been very successful, and it was great. But at Yewno, we don't own content, and we don't sell any content. So we were really interested to understand the results. So if a publisher is going to use this enhanced semantic metadata, can we actually prove a correlation with increased sales? So I wanted to work with one of our publisher partners, and I was looking for somebody. Our office is based in Palo Alto in Northern California, and I was looking for somebody who was willing to participate, keen, enthusiastic as I was to run this experiment, and also conveniently located. So I thought of my colleague here, Alan, based at Stanford University Press, with a reputation for innovation and forward thinking, and I set up a meeting with him to go and discuss this idea of running a pilot to say, if you use this data, you can track your sales, and then we'd love to see the results. So off I go to see Alan, super enthusiastic, and this is what Alan says to me. If we sell one more book, it will be a miracle. So perhaps I should explain a little bit about Alan's background. So Alan, like me, is from England. England is a small island where it rains a lot. We're less optimistic than many people in California. And I'd like to introduce a little bit of history as well of Stanford University Press. So Stanford University Press is one of the oldest university presses, and it was founded in 1892. Today they publish about 140 books a year across humanities, social sciences, and business. And in addition, they have an active digital publication program of interactive scholarly works. And their imprint backlist holds over 4,500 titles. So Alan is a mathematician by training, and prior to working at Stanford University Press, he worked at Cambridge University Press for 14 years. And in his final 10 years at Cambridge, he was managing their West Coast office from the Stanford campus. And he's now been at Stanford University Press for 16 years. So I'd like to hand over now to Alan to talk a little bit about this experiment.
So, as Ruth said, I'm a mathematician, and so that means I tend to be rather analytical when I look at these things. And so, as soon as I joined Stanford University Press, one of the things that I did was institute a pretty rigorous workflow within the press that captured as much data as we could. But we have extremely limited resources. So that meant that the efforts that I put into managing the rigor of our workflow and our metadata system was implemented on the front list. There really wasn't much I could do with the backlist. So as Ruth said, we have 4,500 titles in our backlist. And in the last 25 years, we've gone through 4 different distribution systems. We started off with our own in-house distribution system with our own warehouse. We then migrated across to the Cambridge distribution system with their own technology. We then moved to Chicago, and now we're with Ingram. And each of those migrations has migrated all of our backlist data across to a new system. That includes subject codes, that includes any other metadata that we've got, it includes the introduction of BISAC codes. And when you're migrating a 4,000+ backlist collection across, you can't do that title by title. I know from Cambridge days when we would migrate 20,000 titles across, it's all done schematically. So we did what everyone else did. We produce a spreadsheet, we come up with a correlation between the new codes and the old codes, and we migrate across. And by the time you've done that 4 times, there's almost no relationship between the final subject code and the actual content of the book. Equally, when BISAC codes are changing beneath your feet as you're managing those migrations, we frankly had almost no idea where this landed. At the same time, when we landed at Ingram Academic for our distribution in 2017, we had a lot more opportunity to engage with print on demand, with their core source distribution system for digital content. And so we started to see a lot more pickup of our content. Sales increased by about 25 to 30% for the majority of our list. That was through streamlining the process and increasing availability. But what we hadn't done is tweaked the underlying data. Now, we had what you would usually have, which is the jacket description and the author and the title. So we had the basic details because we've been running those through the Library of Congress and other places for decades. But we didn't have the kind of metadata that many of the library-facing ebook platforms and the commercial ebook platforms and commercial print platforms needed to be able to sort and filter out the content. So as Ruth said, we thought it would be a good idea to have an experiment. We've been playing around with Yewno for quite a while. It's a really fascinating knowledge platform. And when we saw Yewno Unearth and realized that it was generating concepts and topics for our books, those are exactly the same as BISAC codes. So we figured, why not give it a shot? So we decided to come up with an experiment. We wanted to make it limited, just because of time. So we decided, let's take 100 books. And we needed to try and root out as many other factors as we possibly could. So we decided that we would make it books published between 2002 and 2010. 2002 is important because that's when we instituted our in-house database and we actually had fairly reliable basic data for our content. I wanted the books to be old enough such that they weren't influenced by current events, so that there wasn't an author event or a speech or anything else that it was going to be tied to. We also wanted to make sure that these were paperback books, so they actually had a chance of selling. If we picked 100 cloth monographs that had been selling 1 copy a year, then we would have barely noticed the difference. We wanted to pick books that weren't in a really active sell cycle right now. If they were on course adoption or something like that, we might have accidentally picked up a bi-yearly course or something like that. So we decided to set the threshold at about 50 copies a year. And the other important thing was that we needed there to be limited metadata. We had a whole slew of backlist titles that only had 1 BISAC code. And we know from current metadata best practices, which we violate for probably 90% of our titles, that we need about 3 BISAC codes. So that was the criteria for selecting the 100 books. We came up with a list that was quite a lot longer than that, and then we did a digital dice roll to pick which books we were going to work with. And so then we needed to replace the data, so what were we going to do? We wanted to do a fairly light touch in terms of the metadata change. We weren't going to radically rewrite the book description. We didn't have the time or bandwidth to be able to do that. We weren't going to change any of the other details. So we decided to fix on 2 points, and the 2 points of strength for the Yewno system. One was we were going to replace the BISAC codes, and we were going to replace every book with 3 BISACs. And the second was we were going to replace the keywords. So we ran, the first thing that Ruth has skipped over, so I'm hoping Ruth will have time at the end to go through a little bit more of the technology, was that the Yewno engine did need to be trained to actually map its keyword system across to the kind of keywords that we need and the BISAC codes. So we ran 100 books. We did this in, I believe it was September of last year. So from October, November through to the end of March, we had 6 months of sales. So I was able to compare 6 months of sales for these books against the 6 months a year before, just to avoid any kind of seasonal impacts that we might be seeing. So I would love to say I've randomly picked 3 books. Of course I haven't randomly picked 3 books. I've cherry-picked 3 books to show you. And one of the reasons that it's useful to cherry-pick these is because they're not influenced by any outside factors, so the only thing that I can conceive of that's made the difference here is this change in metadata. These are deep backlist books, so the overall trend is down. They're in the long part of the tail, so I would expect sales to go down. And I'm not sort of undermining the exercise here by telling you that on aggregate, yes, they have continued to go down. But my hope is that instead of going down like that, they'll go down like that. Any positive change makes a difference. So here are 3 examples. First one is Knowledge in the Blood. We published this in 2009. It's a $23 paperback. You can see this is the book description that we have for it. It's a perfectly adequate book description. It's a book written by the president of a South African university about the experience during reunification when white students came into the university, and so you basically had a mixed-race university for the first time. It was a really interesting story. It didn't naturally fit in our list at the time, and we didn't really know what to do with it. We've developed a list around this book now. We categorized it as education leadership, and that's the BISAC code that stuck with it. This is what it was changed to, using the Yewno concepts. Now, those are definitely appropriate. They probably wouldn't have been the top of my list if I'd gone from the BISAC list. But this was a neutral experiment. We weren't going to adjust it. But the thing that will probably shock you even more is that the system produced 776 keywords. So I've reproduced the list of keywords here for you. That's massive. There is no way that we could have done this. Every one of these is something that appears in the book. It's something that ranks high enough to be isolated out as a keyword rather than just a random word used in the book. And each one of these associates this book with some concept that our customer may hopefully be interested in. So let me show you how this book has performed. Its lifetime sales up until last year were 2,500 copies. It's a fairly rarefied book. It's perfectly adequately performing for this kind of paperback. Right now, we're selling about 25 to 26 copies a year. In the 6-month period of this experiment, it went up by a factor of 7. There is nothing that's happened with this book. I've had a look, there are no classes, the author hasn't spoken anywhere, it's not been in the news, it's not been referenced or cited anywhere that I can find. So I'm making the assertion now that this changes because of the metadata. Okay, example number 2. This is slightly older, 2002. Deborah Brody is at Stanford. This was her first of, I believe, 3 books with us. She's published with Oxford and various other people since. This is an edited volume about why women are so dramatically underrepresented in leadership. Again, a slight outlier for the bulk of our list at the time that we published it. Certainly gender studies is a central part of our program right now, but it wasn't when we published this book. We categorize this as women's studies. In fact, I very much doubt we actually categorize this as women's studies. I'm pretty certain that we gave it a subject code that alluded to women's studies, and then the BISAC was generically picked from a list. when we did the migration, because this predates BISAC codes. So it was changed to business economics, leadership, and business management, which is interesting. It took women's studies out of it entirely. But again, it came up with 548 keywords, which I've dutifully replicated for you here. And I can flick through all of these keywords and read them. Some of them are very surprising. One of the interesting things when you start to look at the Yewno Unearth data for any of your books is it tells you that they're about something that you didn't think they were about. That's kind of shocking. When I've shown it to our acquisitions editors, there's an initial disbelief of, oh yeah, that's just what a system does. AI doesn't really know what it's doing. But actually, in every case I've seen, it's been appropriate. It does exactly what the name suggests. It unearths things that you hadn't actually thought about as a concept for that book. This book had actually done a little bit better, 50 for 300 lifetime sales, but it was much older, so right now we were just selling 11 or 12 copies a year. And in the period of this experiment, we doubled the sales. Going from 11 or 12 up to 25 in a 6-month period, that's pretty good. And as I will echo later, if we did this across our entire backlist of this age, that would be huge. Okay, one more example. Somewhere in between, Cult of True Victim, book published in 2006. This is actually a cheaper paperback, $20. This actually is much more central to our sociology list. We do a lot about inequality within our sociology program. So this book fits fairly squarely. It was a well-known author. I can tell you this book didn't do anywhere near as well as we'd expected it to do when we first published it. But given the themes of the book, its code had migrated to political ideologies. This was changed to harassment, discrimination, and American government general. And actually, those are ones that I really agree with. But I'm certain that when we went through these BISAC codes, 13 years ago, we wouldn't have thought of most of those. And in fact, probably 13 years ago, some of those didn't even exist in the BISAC list. And it came up with, this time, 790 keywords. These are slightly smaller typeface because there's too many of them. And this had actually only sold 678 copies, and we were down to selling about 15 copies a year. But again, we doubled the sales of the book in the 6-month period. So, of course, the immediate question you say is, when can I do the rest of the backlist in this? So I want to do all 4,000 titles, because if I see that kind of change, even for 10% of the titles, it's made a huge difference to everyone. Even though it sort of pains me to say this, I suspect that the metadata for our front list isn't as good as the metadata that we're getting out of this system, because we're producing it with a combination of our acquisitions editors who know the book inside out but know nothing about marketing and nothing about metadata, and a marketing and metadata team who don't know the book inside out. And what we stand to get out of this is the best of the two of them combined. And it has the additional feature that we don't have to put a person on this. We can save all of our resources and we can produce this. I mean, at the very least, I would like to use this system as supplemental to what we're already producing. But it also opens up other questions, which is that this technology is actually reading the book better than we are. So what else can we use it for? There are lots of little things that we do to categorize and collect our content. And I suspect that this kind of system can do better than a human in just enough of those cases to actually make it worthwhile investing in it. So I finished way earlier than I thought. And I'm going to let Ruth talk about the technology.
Thanks, Alan. So I wanted to explain a little bit, where those very, very long lists of concepts come from and how we can apply BISAC codes. So just talking through from left to right how our technology works. On the left-hand side, in comes content. And as I said, it can be anything from an abstract to a journal article to a full book to an enormous government report. The only thing I would say is Our technology is artificial intelligence, and so you're giving a machine text, and there is a minimum quantity of text that the machine reads to be able to understand context. So for example, if you give a list, books, comma, artifacts, comma, etc., a machine can't find context from that. So I would say think about abstract length, or sort of 160 words as a minimum length for this kind of technology to really give you good results. Then what we do after we've ingested all of the full text is that we run a series of algorithms. And what our algorithms are trying to do is to recreate a neural network model. So they're trying to recreate how all of us in this room actually think. So they're reading through the text, they're understanding meaning, and they're understanding that, and they're promoting that and creating what we call concepts. So a concept could be a single word, or it could be a group of words. But the key thing about a concept is that it's not just a word or a group of words, it has a definition. So if I say to all of you, Java, J-A-V-A, some of you will be thinking about a programming language, some of you are thinking about a coffee, some of you are thinking about an island of Indonesia. I know Paul is thinking about coffee, he's just gone to get one. So the key thing is that a word itself isn't enough. You need a word and you need a definition. And the other thing about concepts is that what happens on the right-hand side is all of those concepts are linked in a graph. And a graph is a fantastically flexible mathematical instrument, so all of us in this room can interrogate the graph, looking for something different, take a different path and take a different journey. And then I think one of the most important things to me is that the graph is always up to date. So it's not a static environment. It's not an environment where you create it and then a week later or a month later your data is out of date. Every single day, if a publisher publishes a new book or a journal article, that data can be ingested and updated. And so what you might see is different connections, or the strength of connections will change as things move in the graph, as new content is ingested. So it's a completely new dynamic environment. And in terms of what that really means, so if you look at the beginning of this, we started off with BISAC and keywords. And that was really to help people find books on bookshelves, whether they were in a bookshop or whether they were in a library. And then we've seen this huge change in terms of the digitization of content, internet access, and search. Now, I'm super old, and when I was at university, I had to go to the library and get my books. I studied modern languages, and so a lot of my books were very unusual Italian books. And if I didn't get there quickly, one of my colleagues would already have taken out the book, and I would have to then wait for it to come back in. So to me, the way in which people can access content now, when I look back to what people in different generations had to do, is just phenomenal. But what it's done is also created a different problem. So you go to a search bar, you put in your query, and you get millions of results. And how do you find the good information? So if you've got 100,000, a couple of million results, there's definitely high quality information in there. But where is it? We know that over 90% of people stop on the first page. That's probably not the best information. So we've gone from very skeletal information to much better information and much better search technology. But what we do with neural networks is we take that one stage further because of things like disambiguation and because we can understand context and meaning. So what you can see on the right is that if you've read the word apple, technology can now understand whether it's talking about apple the fruit or apple the company, because it's read the whole context of where that word or group of words was found. So it understands apple the fruit, it takes that concept, it attaches a definition, and it projects it into a multidimensional semantic vector space with all of the other fruits. We see here, the other blue example is pear. Equally, apple the company, it understands it's the company because, again, it's read the rest of the document, it understands the context. And so apple the company is projected into an entirely different plane in this multidimensional semantic vector space, close to Microsoft and Java, the programming language. And it's probably difficult to read, but the little example at the bottom is about internment, and it gives you two sections of text. And if you read them, you'll read them and you'll say, yep, that's about internment. The word internment itself isn't actually part of the text. So neural networks can actually identify what something's about, even if that specific keyword isn't mentioned itself. So looking at Alan's pages and pages of concepts, pages and pages of concepts need more. So if you look here, what you can see on the right-hand side is this is a journal article, and it has a series of concepts that have been extracted. You can see particle accelerator, electron volt, d-byte length, plasma acceleration, and so on. And each of those things has what we call a pertinence score. So if you had thousands or millions of articles and someone came to your website and they were looking for electron volt, you'd be able to identify the most pertinent instance of that, and you'd be able to rank all of the contents based on some of this pertinence score information and things like semantic fingerprinting, where you'll actually give a semantic fingerprint to an entire document. And then really the final thing I was going to mention is just about keeping content updated. I think one of the most important things for any publisher or for any researcher is to know that the content set that they're looking at is completely up to date. And in a traditional environment, it's very difficult for people to keep working through this new volume and keep connecting all the new items to the older items. But in this world of artificial intelligence, you can keep content up to date on a daily basis in this enormous graph as often as it's published. And typically what we see in the kind of academic content sphere is daily updates, but actually with things like news, you might be receiving updates every 5 minutes. So that's really all I wanted to talk about in terms of explaining how it worked. Big thank you to Alan for sharing, first of all, the experiment after his huge initial success.